Hello everybody! It's lesson 20 already! Hang in there, hang in there. One more month to holiday, okay? So today we're gonna learn Theorem 3 and Theorem 4, okay? So before that, let's check our previous homework first. Let's go! So previous lesson was Theorem 2. If you remember, maybe you can recap back a bit your Theorem 1 and 2, okay? Always recap back so you remember what you have learned, okay? So Theorem 2, equal chords are equidistant from center, okay? So let's go to try 3. Okay, go back to try 3 again. Please double check. Okay, I have checked your work in your PDF that you sent to me. I have already marked. Please open the PDF and check if you have any mistake so you can do correction, okay? And you can double check again here with me. You can mark again just in case if I mislook your answer, okay? So try 3 I already discussed, so that's the answer. Question number 3A is 8, and if you write in cm or units also okay. Okay, cm units also okay because they did not mention what unit is here. Okay, I assume it's a cm, alright? So 3B is 10.2 cm or units, okay? Just tick, Alright, number 7A, this one definitely in cm, 9 cm, and B is 41 cm. Okay? And question number 8 we already discussed, so this is the answer. Right? So remember to copy down this Theorem 3 and Theorem 4 at the front page of your topic. This topic, properties of circles. Okay, so let's look at Theorem 3 first. Okay, so Theorem 3 here tells us angle between the tangent and radius is 90 degrees. Okay, so tangent we know that is this line, the yellow line here that touch only one point of the circumference here. Okay, and the radius is 90 degrees. So this one is 90 degree or right angle. The angle between radius, any radius and any tangent, it will give you 90 degree. So now you look at here, this is your tangent line and this is your circumference. So tangent line touch at this circumference at one point, and this is radius, and these two lines make an angle of 90 degree. Okay, so look at this. Okay, it's 90 degree, always 90 degree in between these two lines, which we call radius and tangent. So angle between tangent and radius is always 90 degree. So that's Theorem 3, easy, right? Okay, let's look at Theorem 4. So Theorem 4 tells us that tangents from an external point are equal in length. Okay, tangent, now we have more than one tangent now. Okay, we have one tangent over here and we have another tangent over here. So we have two tangents here from an external point. So external point is here, right? Okay, and they are equal in length, means that the point where it touches the circumference to the external point and another tangent line where it touches the circumference of that point over here to the external point, these two lengths are equal. Okay, now you look at here, you look at the line, these two lines, the blue lines are, so these two blue lines are tangent lines and they are from one external point over here, okay? And then these two lines are the same. You see, this is 6.71, this is also 6.71. So what if I move my external point? If I move my external point, okay, when these two lines passes through also only on one point at the circumference, these 2 points, okay, these are called tangent, right? The length are still the same, so the length are equal. Look at that. Okay, so that's for Theorem 3 and Theorem 4. Let's go to try 4. Okay, let's go to try 4 and see what is the question. So try 4 in the diagram, TA is a tangent of the circle. Okay, this is a tangent, TA is a tangent to the circle center, or this is center also. Obviously this is radius, and BT equals to 4 cm, AT is 6 cm. Find the radius. Okay, so radius is OB and OA, both are also radius, same radius. So this one, okay, R, this one is R. Okay, so we know that this is a 90 degree. Okay, this is according to Theorem 3, T3, right? Theorem 3 tells us that the angle between these tangent line and the radius is 90 degrees. So this one is 90 degree. They did not mention here 90 degree, but according to the theorem 3, we must know that this is 90 degree. Okay, so this one is 90 degree. What we're gonna do is, this is a right angle triangle. We're gonna find the radius over here using the Pythagoras theorem. So 4 plus r square is also equals to r square plus 6 square. Okay, this is hypotenuse. Hypotenuse square equals to a square plus b square. Okay, so this one I'm gonna expand. You can try to do by your own. Okay, and then you compare with mine. R square, okay, cancel, because when you move over there, minus, so no more also, right? So this one is 8r. So r equals to 20 divided by 8 is 2.5 cm. Okay, that's it. So your radius is 2.5 cm. Easy? Easy, right? As long as you know that this is 90 degree according to the theorem, then you can do already. Okay, so let's go to try it 5. Okay, try it 4, you copy the questions and also the circle. And then try it 5, let's look at try it 5. In the diagram, TP and TQ are tangents. So this is tangents. These two lines are tangents to the circle center O at P and Q respectively. So this one P, this one Q, okay, on the point of the circumference, okay. POT is 65, okay, it's already in the diagram. Okay, so what can we see here is, we know that according to T3 and T4 together, what T3 tells you? Look at your notes. What T3 tells you? T3 tells you radius, with angle between radius and tangent is 90 degree. So where is the 90 degree? Here, here is 90 degree. Here is also 90 degree. Okay, how about theorem 4? Theorem 4 tells you tangents, these two tangents are equal in length. Okay, these two tangents are equal in length. So meaning to say that this length and this length, they are the same. Okay, because it's a tangent line from an external point. This is an external point. Okay, so what do we need to find here? Okay, part A, PTQ, which is this. Okay, this angle over here. Alright, so there are two ways of doing this. Okay, one of the way is I will use this triangle. Okay, this triangle POT. Okay, to find one part angle here, and then I times 2, because this whole thing is these two angles basically are the same. These two angles are the same. Because why? These two triangles basically are the same. Okay, let me explain why these two triangles are the same. Okay, we have a 90 degree here, we have a 90 degree here, we have a same length here, and they share the same length in the middle, OT. They share the same length, OT, share sides, and PT, TQ are the same. If the sides are the same, all the sides are the same, means that they are congruent. Okay, these two triangles are basically the same thing. So if they are the same thing, meaning to say that this angle and this angle, they are the same. Okay, and this 65 here, this is also 65. They are the same. Okay, so method 1, you can find PTO dulu. You find PTO first. Okay, and then you times 2. Okay, because there are two angles here, one angle and one angle. Or you can use, this is a quadrilateral, 4 sides. 360 minus 90 minus 90 minus 65 minus 65. Then you will straight away get this PTQ. Okay, whichever method that you want. Okay, I will just choose pick one method only. I will use I will straight away find PTQ. This PTQ. So I will use 360 because this is a quadrilateral. So 360 minus 90 minus another 90 minus 65 minus 65. Okay, so PTQ is 50 degree. Okay, or you can think like this. In this quadrilateral, since this is 90 and this is 90, these two angles plus together will be 180. Okay, so what you need to do is just use 180 minus 65 minus 65, then you will get this, also okay. Okay, but if you don't understand that one, it's okay. You just stick to this one, also okay lah. Right? Okay, so the answer is 50. Okay, part B. Part B is asking you to find PQT. PQT. PQT is here though. Okay, let me erase first. PQT is here. Okay. So, okay, you see this is a triangle, this is a triangle. And it's the same sides here, right? According to the T4, So if same size means that they are isosceles lah. You see, it's an isosceles triangle. This is an isosceles triangle. Okay, and the angle we already found it just now. This is 50. So we can find this angle PQT using 180 minus 50, and then we divide it by 2. Okay, this is an isosceles triangle. So I get 65 here. Okay, so that's it for try 5. Easy. Okay, let's look at questions straight away. This is exercise 3.1. So exercise 3.1 here, page 91 to 92. Okay, so try 4 and 5, you copy the question. For page 91 to 92, there are questions that I picked here already from 4 until 6. You just copy the circle, you don't need to write down the question. Okay, no need to write down the words, only the circles there. Okay, I will choose a few questions for myself to do, and the rest you do it by your own, alright? But I will guide you definitely. Okay, so for starting from 4B, I will teach you 4B lah. I teach you 4B, then you know how to do 4A. Okay, so this one is according to Theorem 3. Theorem 3 tells us that the angle between the radius and the tangent is 90 degree. Okay, so this is a 90 degree. Okay, so if that is a 90 degree, we minus this angle here, then we can find our x. Okay, because this is 90 degree, we just need to find this angle here, this OAB angle. Okay, and this is a radius. These two are the radius. If these two are radius, meaning to say that 180, when you minus this 70 and divided by 2, you will get these two angles. Right? Okay, so I will find angle OAB first. Angle OAB will be 180, I minus 70, and then I divided by 2. Okay, so I minus and divided by 2, I get 55 degree. So this is a 55 degree. And my angle X will be 90 minus 55. Okay, because this is a 90 degree, 90 degree. So I minus 55, I get 35. So that is the answer. Okay, so I teach you part B already. I think part A you can do. It's the same method. You do it your own. This one DIY. Do it yourself. And then question 5 is the same. Okay, it's the same as try it 4. You can refer to try it 4. I already explained it to you. Okay, according to try it 4, and then you can do it your own here. Okay, and then number 6. Okay, number 6, A, B, C, D. I will pick few questions. Okay, this question they are asking you to find unknown angles and sides. Okay, basically what you need to find is P, X, Y. P, X, Y. Okay, this one is P and X only, and then this one is X and Y only. Okay, so I will do C and D. Okay, C and D here. Okay, this is 90 degree according to Theorem 3. Okay, and then this length and this length is the same. Okay, it's the same according to Theorem 4. Okay, right, so I find my angle X first. Angle X is easier to find. Angle X is, this is 360 minus 90, 90 and 120. Or you can use 180 minus 128 also can, alright? Okay, I will write down the long one. It's okay. But if you understand the 180 minus 128, okay, you just use that method, alright? Okay, so this one, the answer is 52 degree. So my X is 52. Okay, highlight your answer. And then for P, okay, now, to find the length P, you are not given any length here, right? So, if you are not given any length, what you're gonna do is, okay, I separate this. I draw a line like that. Okay, I draw one line like that. And then, this angle here is basically my 52 divided by 2. Okay, because my X is 52. When you divide it by 2, this is 26. Okay, and this triangle is a right angle triangle. Okay, right angle triangle. Okay, I'm gonna draw the triangle here. So this is ATO, you are finding P, and this angle is 52 and this is 10. Okay, so I'm gonna use tan. So tan, toa, I'm using toa, T-O-A. So tan 52 degree equals to 10 over P. So my P is 10 divided by tan 52, and I get 20.5. Okay, 20.5 cm or 20.5 also can. So my length of P is 20.5. Alright, 20.5 units lah, or cm. Okay, so that's all for C. Okay, and D, I'm gonna do it also for you guys. Okay, so part D here, you're finding X. Okay, this is an isosceles triangle. Why? Because this length and this length, they are the same. Okay, tangents from an external point are equal. So definitely it's an isosceles. So X is equals to 180 minus 54, and then I divided by 2. Okay, so it's 63 degree. Okay, and then for Y, okay, I think for Y also easy. This is 90 degree, this is 90 degree. Okay, so this is equilateral triangle. 180 minus 54 to get this Y also can, or 360 minus 54 minus 90 to get the Y. Okay, so Y, you do it yourself. Okay, I think the rest of the question is easy, kind of easy for you to do. Right? So I hope I have guided you much on this Theorem 3 and 4. Okay, so for lesson 20, you do try it 4 and 5, and exercise 3.1, number 4, number 5, and number 6. Okay, alright, that's all from me today. Alright, thank you guys. See you guys again in next week. Bye.